Hello, hello, ahoy, ahoy. We are back with Pressure Games Tech Tuesdays. We have a new partner here today. This is Nathan. He's been shuttled off into another room for a while now because he's 5 and sometimes goes like this too much. So we're going to try and have him on the video. We'll see how it goes. Of course, we have Sebastian here.
Hi again.
And we have Alexis behind the camera.
Yep.
Last week,
What? She's doing a bunch
I'm
of
being
weird
told to hold
movement.
on. Okay. So, last week we took... What did we do last week? Sebastian, do you remember?
We did the face.
We did the face.
No, we did the speakers and the face.
That's right. We worked on the speaker and the face. So, we learned how to actually make sound out of different things. Everything we've done up until now has been using programming to control what we're doing. Today we're going to learn a little bit more about electronics and not do as much of the programming. Today we're going to learn about some of the really...
We're going to make a
Yes.
fan.
What are these?
We're going to turn
talk
this fan on. It's
We're-
actually super easy.
We're going to turn that fan on. But we're also going to learn...
You just need to plug it into ground and power.
We're also going to learn how to control the speed of the fan and how to do different things without having to do programming. Because for a lot of toys and different things you have, they might have a fan in it, but they don't want to use a whole processor, which is expensive and takes time to program to actually control the speed of just a fan or to control the brightness of a light. It's fine. He's holding a fan right now. He's excited about the fan.
It's actually super easy to make it work. You just plug the red wire into power and the black one into ground.
Well, let's get there. Do you want to actually show how to make it work? So we're going to do
Sure.
the easiest setup right here. If you can set over to the board. We have 5 volt from the board going into our breadboard here.
So
And
red,
Yep. And we have ground.
black is like blue. It's dark, so
Don't
that can help you remember. And red is red for power. And so you have to hold this up so it doesn't kill the ground.
Okay. Now give everyone a minute and let me explain how this is set up for a second. So power VCC, or 5 volts, is going into the red here. And then, let me explain without making so much noise. Then ground is going into the negative over here. So
It's gonna get my nose.
I'm going to turn that down because it's really loud.
No.
Okay, don't plug it in.
It's
Please
fun.
don't plug it in.
It's fun.
So 5 volt goes into the plus, which then is going to go into this red wire here if we plug it in over here. Ground is going to go in here to the negative, which then is going to go into this wire over here. And
I
so,
literally just felt your phone vibe. But
as Sebastian said, when you plug it in, it's going to turn the fan on. Now, not all devices, or this device is actually really special because a motor usually can turn in 2 directions. So you probably won't see it on the camera, but if you plug it in this way,
and when you take it out, it starts going this way.
let's get there. So
And
when you plug it in,
when you switch
you've got to calm
the
down.
order of the wires, the black and red and the red and black,
It's going to
it
spin.
goes the other direction.
That's
it
right.
goes right for black and red and red and black.
That's correct. So we can actually choose which way the fan spins by which way we power it. So
Oh, it actually spins better with the red and ground because it spins
you'll have to
because
test.
because it does it outwards.
You'll have to test because you
So-
might want the fan to suck air in, or you might want the fan to blow air out.
Like
So-
for sucking in so it doesn't smell as bad after farts.
Yes, that's exactly why. So, what?
What?
But yeah, so for a lot of the times when you
I
cool
smell fart.
something, you want to actually suck air in, so that way cool air gets into whatever it is that you're trying to cool down. Sometimes you want air to blow out, like if you're trying to fan yourself down. So a fan like this, you can actually choose which way it's going to blow by which way you connect the power. And so that's a really neat thing to do and something you can be aware of. Not all things are like that. Like lights have to be plugged in a special way because there's no other way for a light to go. It's either on or it's not on,
Yeah.
right?
If you plug it in one way, it's not on. If you plug it in the other way, it is on.
So now we're going to try a close-up.
Sure.
Yep, we want to plug it in, just those 2 wires.
I just have a question of my own.
Sure.
Is there a way, like, with plugging in to make it not...
Guys, I got an idea.
With
If
plugging
you
in?
unplug this and don't put power into it.
Well, so that's actually a really good question. So right now, let's say this fan is either on a lot. Let's lift it up so the camera can see it. That's what the point was. So, I mean, this is as simple as it gets. Please stop putting your finger on there.
It makes me warm because friction.
The negative side or the ground side is in here, and it goes over to any of the wires over here. Again, it depends on which way you want to plug it in. Yes, Nathan.
What about the resistor?
Why can't we try to put them both in the same one?
Because then it won't do anything. If you put them both in the same one, you want to know what's going to happen?
It's not going to go.
Absolutely nothing. Because you weren't here for it, Nathan, but we are not connecting the circuit. The circuit is, power is going in here.
And then it's just going to the fan and stopping.
Yep, it's actually not going to hurt anything by doing this, which is pretty neat.
Adrian Andre says, please repeat the question.
Ah, okay. Sorry about that. Thank you, Adrian Andre. So now,
She's your sister. Do you have to go?
like I was saying,
Daddy,
yes,
no,
Nathan.
I want to plug them.
Okay, you can play. Like I was saying, this right here is either on or off.
I don't think they can see it.
When we plug those wires,
I'm just trying to
Please
see
stop.
if it works.
when we plug those wires in, this fan turns on. It turns on as fast as it can go because all of the power from the pin is going straight into the fan. That may be what we want, but if you imagine we have some super big, powerful fan, that might be too much. And so here's where we come into using resistors, which are the little blue,
I already got one right here.
these are in the little blue pack that you got.
This
There's
one has brown.
Please, Sebastian,
black,
please stop.
something.
So in each pack that you have, there's a little blue number that's written on here. The higher the number, the more the power it's going to resist. And if you resist more power to the fan, what do you think is going to happen?
It won't go as fast.
That's right.
But
So
guys,
some of these
guys,
have resistance of 10 million.
but guys,
If you put a 10 million resistor in there, the fan is not going to spin at all.
everyone, if we put it right here, it won't move at all.
Because
That's right.
power is not coming from here into there.
That's right. Nathan, you need to complete the circuit, right? Can you say that?
we need to complete the circuit.
That's perfect. So now let's try. I believe this is 100.
Are they on the webcam,
I don't know where they
Alexis? Are
are.
they?
She's the boss. Let her do it.
I'm asking if they are.
It doesn't matter. We can watch later and see this whole video for ourselves. So
See?
we're actually going to try a 10 ohm resistor. So this
What does
is
10 ohm mean?
10 is really, really tiny. But let's put it in there between power. Nathan, Sebastian's going to do something,
No,
okay?
here and then here.
Let's put it over here into one of these. Like, let's put it in number 15 over here.
Why
Put
can't we
it
put it this?
because
on
that's not
this
going to
side?
work down.
What?
Oh, because this is the halfway mark?
They can't see.
Just put it over here. Put it between power to
What?
when we're done. Yes.
I don't hear it.
No. Don't put it between those two. That was not good.
You said
So-
put it between.
I'm sorry. Sebastian just burned himself a little bit.
Come here.
So Sebastian's going to take a break. If you put this in between the power and the ground, it's actually going to get really hot really quick, and that's going to hurt. We don't want to do that. We want to put this from the positive here over here to one of these in the middle here. And now if we push the power here to ground. So now if you look at the circuit, the power is going to come in here. It's going to be slowed down by this resistor. And then the power is going to go into this wire and then go over to the ground. So this right here, you might not be able to tell from the camera, but it's actually spinning quite a bit slower right now. We can try different resistors at higher values and slow the fan down
Dad,
even more.
But guys, it looks like it's going faster.
It looks like it's going fast. Well, then that's ruined my experiment, Nathan. That's not good.
No, but it did a little. Looks like it's going faster. Does it?
It might look like it, but it actually is going slower. If you try this,
I know.
we have in your pack, there's 10 ohm, there's 100 ohm, there's 1,000, which just says 1K. K means 1,000. And so we have a question.
From me.
This is from Alexis.
So you know the one that you just put in, like that blue one.
A 10, yes.
Daddy, can we
What
take it
would
out?
be the difference between a 10 and a 1K?
A 10 and a 1K.
But
So
Daddy, can we take this out?
you can if you want. So a 10 is only going to slow the power down a little bit. So the fan's only going to go a little bit slower. If you go to 100, that's 10 times more than 10. So it's going to go much slower. And I think once you get up to about 1K, the fan's not going to spin at all. There's not going to be enough power to make the fan spin at all. And so that's where you as a designer, you have to pick the right value for what you want to do. Sometimes you want a super fast blowing fan that uses a lot of power. Sometimes you want a fan that blows a little slower and doesn't use as much electricity. The batteries might last longer and you can use that power for other things.
But Daddy, why can't
But Nathan,
we put them? Why?
oh, you can see that was faster.
What?
So he put it in this red one over here, and let's see how fast it goes there. So this is an easy way to test. You put it in here, really fast. Hold it in there. So he's putting it in. Let go. So put it in. So he's just putting it in this red one over here. Super fast. Move your fingers. That's super fast, and you probably can even hear it a little bit more. And we put it over here into this one with the resistor.
Goes a little slower.
And it's going to go slower. So that's a resistor. How are we doing, Sebastian? What happened?
I plugged.
Come on over.
I plugged. Nathan.
It's okay. Just stay right there. Tell us what happened.
Okay, so I plugged the resistor
Take it off for a
from
second.
power to ground, and like you said, it got really hot. And since I had to push it in to plug it in, it
Daddy, look, it's getting
burned
hotter.
my finger.
That's right. And so that's a really important lesson here. A lot of the stuff that we're doing, we actually have the power on all the time. If you make a bad connection between something really bad can happen. A lot of the best way to do something or to set up a circuit is to disconnect the power, plug in what you want, make sure everything is right based on whatever you're following or who you're listening to, and not jumping in and just doing what you think you need to do. For that, he connected power across a resistor, which only slowed down the electricity a little and went right into ground. What that meant is that that little resistor was trying to slow down the power, but it couldn't slow it down very much, and all it did was heat up. That can really get hot. If you put a really large value in there, like 1,000, it wouldn't really heat up at all because it would slow down all the power and there wouldn't be much energy in there. It wouldn't get hot. But when you're using some of those lower value resistors, they can get really hot really quick. So you need to be careful always. And again, it's best to unplug a board before you put it in. We're not perfect at this.
Look at the signs.
I've been doing this for a long time, and so generally I do things while they're still plugged in. I have been hurt before. Sebastian just got hurt. Please be careful with the electronics always. So now we have a fan, which we've learned how to slow down. Next, we're going to use a little bit bigger of a resistor, and we're going to...
Move. I don't think they can see me at all.
Next, we're going to go with a light and a
Guys,
100 ohm resistor.
guys,
So,
look.
yep,
Is this
we'll get to
pretty
that.
cool?
We'll get to that in a second. To
I'm not
explain the
plugging it in.
capacitors. So this one here, we're using the resistors that show.
But
Can you
guys,
please plug it in? I don't want to.
I will. This one shows a 100 on here,
Guys.
so we're looking at the 100
guys,
resistor.
is this pretty cool?
That is pretty cool. Those are capacitors. We're going to get to those in a second.
What are those for?
I will show you in a second.
Okay.
So over here, we're
Can
going
they
to
see me at all? Because I'm squished.
put our resistor from power over to one of these, and
I'm
then
not touching it.
our light.
No,
Oh, so it will turn the fan and light on, but the light will be dimmer and the fan won't go faster.
Well, we'll see. So here's a light with a 100 ohm resistor. Pretty bright. It's pretty darn bright.
But when we plug the fan on, it'll be dimmer because...
We're not going to do the fan right now. We're
Wait,
just going
can
to...
we do the fan too? I want to see what it looks like.
We can, but not this moment.
No, please.
Actually, okay, fine.
Okay.
Plug the fan in. Let's see what happens. So this is a 100 ohm resistor.
Can I plug it in?
No.
Nope. It's got to go in the one above it. It's got to go in one of these over here. There. And that needs to go... Hold on. Yep. Plug it into this same row over here. Nope. Over here.
Right there.
Because you want to plug it in the same row with the light.
So
Why?
Because you need to complete the circuit. The power is going to come in this wire. And let's see what happens.
oh, the light is brighter,
The
and the
light-
fan is going slower.
And the light is going slower, and that's actually really strange. Why is that happening? Do we have this hooked up?
So you do this, and it gets dimmer.
Oh, I think we have the pins disconnected. We're not going to fight over this, boys. So, Nathan,
No.
we're not just going to keep pushing wires in, okay?
But guys,
So let's see. So negative goes in over here.
it's slow. It's not. It's a little bright, but then it goes brighter.
Yeah. And so the way that was hooked up before, we were actually delivering power in a different way. So
Oh, we were delivering power because it was in power.
this is not a good example. Let's not plug the fan in right now, because that's getting into where you're trying to power multiple things with one wire, and that gets a lot more confusing as to what's going to happen there. So let's just move our 100 ohm resistor up to a 1000 resistor.
It's not gonna turn on. Like,
Well, let's
not
see.
gonna turn
So
on.
we put in,
I'm not touching it.
Okay.
Actually, fine. Can I?
sure, 100 ohm resistor.
I'm plugging it into here first.
Okay, we're switching a 100 ohm resistor to a 1000 ohm resistor.
So you sure it's not gonna heat up?
If not, if you do it right.
Oh,
And so what do we have there?
it's
We
not
have
as bright
a much dimmer light.
because it's slowing down more
What?
electricity.
And so again, for some toys, you don't want a super bright light. You don't buy a light that's dimmer, you actually just change the resistor value that goes into controlling that light. And so from this, we can actually do... Now let's plug another light in. Will you do another light with the same type of circuit here?
Sure, this light will be dimmer, and this light will be the same.
Goodbye.
Oh,
Bye, Nathan.
bye
Hug.
Nathan, have
Hug.
fun.
Do you want a hug? Don't tackle me.
Oh boy. And that's gonna go good.
Daddy, can you please help me?
Nope, he's going. All right,
I want to plug it in.
Do that.
I'm plugging it in.
our audience needs excitement here.
Why can't we just plug it into here and put it in there too?
You can try it and see what happens.
If I can even get it like that. Oh, it's dimmer.
Actually, yeah. So
How come this one is brighter than this one?
I don't know. I think they're just different lights. But you can see as you plug it in, if you plug in the same two lights, the power is going to get equally spread between them, so they both will get a little bit dimmer while you're doing it. So again, this is all power. If you have power going into a circuit, a resistor can slow it down, and if that power has to
Oh,
spread up...
Daddy, look, it's just touching the wire, so it turns on.
So if you spread that
Very
power...
cool.
If you spread that power to two lights, each light is only going to get a little bit of it, so they're both going to get a little bit dimmer. If you use a higher resistor value, the light is going to get dimmer. These are a lot of different things that you need to be aware of when you're setting up a circuit to decide how you want.
Can you change it
The
to
light
this?
to be-
I want to show them something. Okay, so instead of plugging this light into that same row, you can actually just put it on the wire, which has an electricity flow, and they're sharing the same.
Yep. So let's turn it to the side so they can see. So he's actually connected this metal to the metal of the other light, which does work. There's a real big problem with doing this though. And the issue is then you have this wire that's just hanging out here. And if it happens to touch this wire over here, let's say,
It's gonna explode.
you're going to get something really hot again, and something bad's going to happen. And this is really loose right here. It's really loose. Your circuit's not going to be very reliable, and there's a good chance that something bad is going to happen there. So yes,
Okay, I'm not touching it.
these metal pieces can touch each other, but you really don't
But
want
what
them
if
to.
that one touches this?
It depends on what it touches. Bad things can happen.
Can
Nothing
this
can
touch
happen.
this?
The best, let's not say, can it touch this and then do it, okay?
Can it?
Because that's dangerous.
Daddy, can
That
it
can,
touch?
it can,
But
because
does it turn on still?
all of these are connected to the same hole here. So,
No,
two,
but- no.
I know what you're saying.
No.
You can
Can it
touch it
touch
to this.
that
over.
metal thing?
Yes, because they all get connected there. They're all the exact same spot. But let's not teach the viewers to do that, because that's not the right way to do
I
it.
just
We
wanna
want to put
see.
it. Yes, you can.
Oh.
Because underneath here, all there is metal. Inside of each one of these rows here, there's metal. So when you connect one wire here to the hole, or if you connect it to another one, it's
And
the same thing.
electricity is just flowing through it
Electricity
constantly.
is just flowing through. So you can touch right to the metal, but again, this board, the whole purpose of this board is to hold the wires in there really securely, so we aren't just letting wires dangle around, get hot, and cause problems. So there's only one more thing I really want to show this week, and that's a capacitor. So there's two real basic materials.
Can I
when
touch
you're,
it?
Yes, you can. I'll show you what to do. Do not put this in wrong. If you put a capacitor in wrong, they can explode. So we are going to take the power out. It can. It's not going to be an explosion like you see in the movies. This is not movie magic here. It can get bigger and bigger and bigger and pop. You do not want that to happen. There is really, it depends. I mean, it can explode. This has metal on the outside, and on the inside are some really nasty chemicals. This isn't meant to say that these are really dangerous items. If they're used
I'm not
properly,
plugging in it.
every toy, every electronic device has hundreds of capacitors in them. They are very safe, but just like everything, you should do it the proper way.
I'm not plugging in.
So the proper way here is on one of these these are called cans. There's actually, is it on me? Can they see this?
It's
There's
black.
it's all colored, and then there's always one side that's colored a little different.
Can I see?
We only have this black one here, but there's black, and then there's one side with white color, and it actually has a line through it. That is a negative. So like a negative sign, like a subtraction sign. So you have
So the other, that means that side goes to ground and the other side goes to.
That's right.
So you know which one, and not just by which one is longer, because you might not.
That's
be
right.
able to-
Even
Positive.
I'm sorry.
Is the other side positive?
The other side is positive. It does not show it as positive. They only mark one side as negative. But if one side's negative, you know the other side's positive. So capacitors, what capacitors are like little tiny batteries. When they're hooked up to power on this side and ground on this side, they don't have to go directly to a light. All they do is they take some of the extra power and they store it in here. And the important value of that is you have like a little battery next to your light. And so we'll show how,
And just in case the power goes out, it still has a little more power.
in case the power goes out, or let's say you turn a fan on over here, all of a sudden that fan might take a lot of power. It might take power from this side of the board. So if you have a capacitor over here, for that brief moment when the fan starts up, this capacitor can keep supplying power to this side of the board so something bad doesn't happen over here, like a light doesn't go off, or something that really is critical that needs to happen over here can still keep going.
Are we doing any coding today?
Nope, we're not going to do any coding today.
Okay, so why is there the coding thing up?
I just put it up. So we're going to put these in. These do go across the pieces that you put the resistor accidentally across before. So again, we're going to disconnect we're going to disconnect the power over here, because again, we want to, after we plug it in, we
Should I
want to make sure it's right.
Should I unplug the resistors?
No, actually we'll unplug this extra resistor over here because this one's just not needed right now.
Can we unplug these?
No, let's leave those in there because this is going to help us explain what we're doing, what the capacitor does. So now, do you want to put this in? Be careful.
How do I do it?
So the
Okay, so-
negative side is going to go in the blue stripe over here, which is negative. And the power side is going to go on the red side over here. So if you think about
It's
it,
already starting to get hot.
it's not starting to get hot. That's your imagination.
No, I can feel it. I can feel it.
You're going to be scared of this for a long time now, aren't you? Okay.
I don't want it to blow up.
Now, if you look at this, we have power coming in on this side.
Can I plug it in?
Wait. We have power and ground coming on this side. And like I said, this is sort of like a battery right here. So here we have power and ground. And so if this gets disconnected, this will be like a little tiny battery for just a minute. It's like a little rechargeable battery. It's going to lose its energy very fast, but it will keep the light on a little bit. So do you want to plug it in?
I'm doing it.
There's fear here. There is dread in plugging this in. You got to hold it with the other hand. Come on. Do it the right
I
way.
don't want to get electrocuted again.
All right. Now, for all intents and
Okay,
purposes...
now if we plug this
Stop.
in.
No, we're not just plugging in other things. For everything you see here, it looks just like normal. The big difference here, and I'll unplug it, excuse me. If you can see it on the camera, and I don't know if you will, if you unplug the USB... Oh, the light didn't even stay on any extra there. It should have stayed on a little bit extra. We'll have to use another one.
A bigger capacitor?
Well, you
Or just
can
another?
double it. You can double it up. I'm going to put
I'm
this.
going to.
Okay, do it real quick.
Wait, so what happens when you double it up?
You just add an extra battery there, so you have a little more power that will hopefully stay around a little longer this time. So I was trying this earlier, and basically you should see this is too close because those wires were dangerously close. It's better to have them separated. So
Wait,
again, we're
this isn't
checking.
Don't plug it in while I'm touching it.
Don't push so hard. Don't push so hard. It
I'm
doesn't-
plugging it in.
Okay. Plug it in. And then we'll unplug it. And there's still not really much of a charge there. Let me try this different.
No, why? How about there's just no resistor?
No, for an LED, you always need a resistor because the
Why?
LED needs some. It needs you to slow the power down because otherwise the power will go through it, get hot like you saw earlier. Some things need a resistor.
And blow up.
So let's
Wait,
try.
I'm going to.
Well, we're not even seeing any real charge sticking around here.
What is supposed to happen?
Well, so the
I'm
light.
just gonna get a bunch more resistors.
We don't have any more big capacitors like that.
We have two.
Sit back. Please
We
sit
have a
back.
couple.
Please sit back.
A bunch.
So I'm gonna.
But they're not as big.
That froze. Okay. Sit back.
It froze.
Okay. Either way,
Is it safe to touch these?
when there's no electricity going through there, is there a circuit right now?
No.
So it's perfectly safe, other than they're pointy and they might poke you.
Ow! Ow!
So he has to find a way to hurt himself. All right. So really what we've done now is we've explained resistors. They help you slow electricity down. That's important to decrease the brightness in things, to control power usage, to slow a fan down, to do different things that you want to control how something's going to operate. A capacitor, on the other hand, is a way to deliver power to something. It helps make sure that a light stays the same brightness always. So if
This has already been 30 minutes.
Yep, it has, and we're finishing up. If a fan turns on, which uses a lot of power, it makes sure that another light doesn't get a little bit dimmer. If you've ever turned on a washing machine or a dishwasher at your house, you might see the lights flicker a little bit or get dim for just a second. If there was a big capacitor near those lights, then that would supply those lights with some power so that way they wouldn't flicker or dim when you turn something else on. Those are two
Weird dance
extremely important things. I think she's making fun of my hand movements.
She's doing
because
a
I'm
bunch of
going like
dance
this.
moves.
Yeah, well, I do sort of look like I'm on
She's
TikTok right now. So, resistors and capacitors, what we did today, again, wasn't super exciting. It's sort of like our first video where we just talked about circuits in general. We're going to try and use this for the next video with programming, with lights, with
Why
capacitors.
is there so many more? Why is there so many resistors?
There's tons of resistors because you might want some lights really bright, you might want some fans really slow. There's the different sensors that we have. There's ones that measure water, there's ones that measure
Really?
measure light if something's bright. But a lot of the way that you control those types of sensors
Can we
is
do
by
solar energy for this?
we can do a light sensor on there. So you can do if the lights turn off in a room.
Alexis is snapping her fingers. What do you mean?
Stop.
What?
If a light turns off in a room, then you can have this turn on a light. So we can have a sensor to say, oh, it got dark in here, automatically turn a light on. And maybe that's what we'll do next week. So we'll keep adding these sensors together and figure out how to make something super big one day. Yes. I like how you tapped me on the shoulder, like I didn't know you were there. Go ahead.
Okay, so how is there a water sensor? Wouldn't it just the water get into the board and...
It has to be made a very special way, but you'll see it's just it's a long board that you can stick like down on the side of a glass.
So if it's out of water, what?
We know.
So if it's out of water, you could program it to beep when it's out of water.
Correct.
Or when it's in water, it can just do like...
Correct. So you could have something, I mean, for really big examples, for a water sensor at least, you could have something that fills your bathtub up, and once it's to a certain height, the water automatically shuts off.
Really? That's
You
cool.
could. Yeah, that is cool, isn't it? There's some cool things you could do like that.
That is so cool.
So,
I want to do that.
Or if it rains too much, you could have a sensor that says, oh, it's raining too much, turn the sprinklers off. There's a lot of different sensors for things like
It
that.
could do beep, beep, beep,
Yeah,
beep,
because we love those noises.
beep, beep, beep,
But so,
beep.
okay. So that's what we'll keep going down. We learned about capacitors this week. We learned about resistors. You might not know exactly how to use those best in a project. The general thing to understand right now, resistors can slow down power. Capacitors give you like a little battery
I
on
think
your
that's
board.
exactly what it should be because it really alerts you and annoys you.
We already have that. All right. So that is Tech Tuesday for this week. We hope you'll be here Tuesdays, 1 p.m. Eastern time on Facebook, and then we always post them on YouTube afterwards. So wherever works best for you.
And Facebook and Twitter, right?
Well, we share to Twitter, which points to Facebook, or maybe I don't know. I'm not in charge of the social. That's Liz.
Ask her.
Thank you so much for watching, and we hope you'll join us next week or watch it after we post it somewhere else. I'm Alex. This is Sebastian. Our lovely director behind the camera is Alexis.
Are we just doing this whole
we're
thing
done.
again since you're saying...
We're saying goodbye.
Oh.
Thank you very much.
Bye. Do you want to see Alexis again?
Have a great weekend.
Yes.
Or great week.
Let's see
and we'll see you
Alexis.
next week.